Okay. You're going to find a lot of stuff in this chapter as you've seen it before. So if I don't spend an ungodly amount of time on it, don't hate me, but you've already seen it. A lot of the stuff you would have seen like in previous math classes, including all the way back to middle school. All right. Well, regenerate. Ready? Set. Phones away. Notebooks out. I'm on 3-1. Okay, quantitative data versus categorical data. Okay, quantitative data versus categorical. Quantitative falls into two categories. You have discrete and you have continuous. Discrete quantitative data would be like you're counting whole numbers of things. Like you were saying, how many cars are parked out in the parking lot out there? You don't have 58 and a half cars out there. Well, some teachers drive half cars. You're not going to get a portion of cars. If you're counting cars, you can count for whole cars. So quantitative data that's under discrete, you're counting whole numbers. Continuous means you're including the decimals, the fractions, everything else. And then categorical is you have categories. Okay? And we'll go over that in a little bit. And a lot of times categorical deals with bar graphs. Okay? Why do we use pictures? People like to look at pictures. They tell a story. Okay? But it's actually a really bad way of doing statistics. There are a lot of newspapers, magazines out there that are going to try and influence you by using some sort of picture. USA Today does it best, in my opinion.
Graphs.
Yeah, USA Today likes to do this. Here's your pie chart.
What about that one guy that makes like the stock?
Kramer?
Yeah.
So USA Today likes to do this. Look at this pie piece. This means something. And they're putting this out as 3D at you, and then they're going to have this caption saying, 23% of 60% of Americans do this. Kick their dog. I know, but I'm just saying. So a lot of times they have this 3D image that's being projected at you to try and get their influential point to you. They're trying to win you over. And you point to the anti-dog kicking, of course they do. No, but I'm just saying. Okay, how about this? They're against teenagers and using their cell phones. Like, dude, I hate this. I'm not going away. All right, so a bar graph is just what it says. Bar graph, you basically have a certain amount of data in each category, and you're counting. So your bar graph is pretty simple. I don't kick dogs. Okay, bar graph looks like this. Big error that they will use a lot of times in bar graphs. I freehand drew this, so I'm hoping my bars are the same width. But a lot of times, the width of these has to be the same in order for it to be acceptable. Okay? And then all this does is it counts. So there's 2 people in this category, there's 5 people in this category, there's less than 5 in this category, is all it's going with it. Bar graphs, it's pretty low end. Bar graphs, pie charts, they're pretty bad ways of looking at data and making a decision off of data. It's just a way to break the data up into a category. We could easily make a pie chart here. We could say the number of people wear glasses. We could make a pie chart of that. We could do guys versus girls. We could do people who have the same color sock on each foot. There's different things. It doesn't really mean too much, but it's where they go into a lot. On a pie chart is all done in percents. And all of the percents need to add up to be 100% as far as a pie chart goes. So a pie chart, They usually have them like a little bit more color coded or some sort of thing that makes them look a little bit different for each region. But if I add up each of the regions, it should add up, it needs to add up to 100%. Usually there's some sort of legend to describe what each category is in the pie chart. Okay, so we're talking about bar graphs, talking about pie charts. Both pretty cheap ways to look at data, nothing through the roof. They get into something called histograms. A lot of times people think a histogram is also a bar chart or a bar graph. A histogram is like a bar chart, but it's different. It's connected. It's together. There's things that we could say about a histogram as far as ideas that go with it. Histograms are columns plotted in numerical order on intervals in a single quality, okay, or single quantity. So the histogram, each of the bars should be the same length. So if you were to start counting to 0, 1, 2, 3, 4, 5, and 6, where the 0 category is here, the 1's here, the 2's here, the 3's here, 4's here, 5's here. We don't have a 6th category, but that's basically how we go with it, how we count. The histogram does tell you that you have, let's see, I'm looking at this, I skipped something real quick. Okay, 5 to 8 bars, vertical axis frequency, this part of your notes already in there. Horizontal axis is continuum of values, not just whole numbers, so it's continuous, you're including the decimals and the fractions when counting up stuff. When does the shape of the, what does the histogram tell us? If the one that's particular on there is more of our data is under the 60 category, so 60 and to the left is where most of our data is at. Most occurring range on the bar graph that's on the lower right hand corner of this page is between 50 and 60. It's the tallest bar. And then how many people were surveyed? So if you look to the side and you look to how many people are surveyed on there, between the 20 and 30 range, you're talking about 2 people. Between the 30 and 40 range, you're talking 4. 40-50 range is 4. 50-60 range is 5. 60-70 range is 3. 70-80 range is 1. Nothing between the 80-90 range, and then between the 90 and 100 range, you also have 1. So you would just add 2, 4, 4, 5, 3, 1, and 1 together, so you'd have 20 pieces of data in there. So you're looking at the height of the bar graph. You're counting how high that goes. You know, most of the time, if we're going to ask you to do that, it's going to be to an exact number, so you don't count it pretty easily. Everyone still with me? Okay, median age. The median age. So the median is the middle piece of data. In order to find the middle piece of data, you have to have your numbers in a sequential order from least to greatest. You find the middle number or numbers. If there's even a number of numbers, you find the 2 numbers that are in the middle. Add them together, divide by 2, and that gives you the median. A lot of times, the median is used when you have outliers of data. Okay? Median a lot of times is used when you have outliers of data. So let's take an example of, let's go to the Cherry Hills Farm area. There was a house, it's no longer there, but some of you might remember this. There was a house that had a large piece of property, but it was like a 2-bedroom, 2-bathroom, little tiny house. You guys know what I'm talking about? And then it's surrounded by homes, perhaps they're your homes, I don't know, that are larger homes. But there was a woman who had lived there. She lived there alone. She lived there since the 40s. She lived there before this became the place to, if you are, much more affluent, you are purchasing a house. So this particular lady had this 2-bedroom, 2-bathroom house that probably sat on about 10 acres in the middle of the Cherry Hills Farm area. Okay, and then surrounding it, you have these houses that are up in the tens of millions of dollars. So the average price of the home in that area was influenced dramatically by this 2-bedroom, 2-bathroom house. So what they would have done in order to get a good evaluation of what the cost of houses are in that area, they went to the middle number, the median number. The median is not influenced by outliers. It's not tugged to the right or to the left. The mean, which is the average, is. Okay? If you were to say, like sometimes, have you ever heard of classes saying, we'll drop your lowest test score? Have you ever heard of something like that? Why would they do that? It could be an outlier. You might have had a day that was an off day. You might have had a day that, someone kicked your dog and you were mad. And you went in, your mind wasn't there to take the test. It might have been me. And so, if they eliminate your bottom test, that should give you a little bit better representation of what you know. Now, there are some classes out there, and you might come across them in college, that will eliminate your highest and your lowest test score. And then also you're like, well, wait a minute. Why are you knocking out my highest test score? Well, there might have been a test that might not have been written at the same level as the other test, so we want to eliminate that. And that's where people start getting a little, hey, wait. You can eliminate that low test score all day long. If you take out my high score, that's helping me. Well, the high score, yeah, it is helping you. Is it truly a true representation of what you knew? If you had, let's say you were taking a test and you came across, I don't want to make it phrased the same way. If you were taking a test and let's say everything you knew was on it, and the teacher realized, oh shoot, I gave the wrong test, but I'm not going to go back. Like if I were to give you, like color by numbers test, you guys would be like solid. Except for the colorblind kid, he's like, everything brown. This kid didn't pass. Okay. So eliminating sometimes the highest and lowest scores, you're eliminating the outliers, which gives you a little bit better representation of the data. And then the last thing I want to talk about is something called the dot plot. And a dot plot is a lot of times just like a histogram. So if I were to do a dot plot of this, they have, X's or dots. Something to indicate how tall things are. Okay? So I'm using X's just because my dots you probably have to squint a little too much at. And this is small amounts of data are used to look at this. You're able to see a pattern in the data. The problem with looking at a pattern in the data, a lot of times people, including in the educational metropolis world of you guys going through school, a lot of times schools will look at data, make a knee-jerk reaction to what the data says. And it's not right. It's inconclusive. It just happened to be, hey, take a look what happened here. It's like that terminology I had used that the Native American male that's on free or reduced lunch here at Cherry Creek High School, the one student that fell into that category was not college ready, but that said that 100% of that student that fell into that category was not college ready. I mean, think about how you can categorize yourself. You got your male-female thing. You got the hair color. You got the eye color. You got whether you have both parents at home, whether your parents are separated or divorced. There's so many different categories that I could separate you into. And if I were to go through and start looking at categories of each and every kid, and then make a conclusion off this. Like if I were to say, I don't know, who should I pick on? We'll pick on me. I'm a safe target. If you were to look at Tempe, Arizona, and find blonde-haired, blue-eyed kids in high school that had both parents, had one sister, dad owned his own business, I fell into that category. And then I take a look at how this kid tested gone. Look how Chris Sturrow did. This must apply to every kid who's blonde-haired, blue-eyed, has both parents at home, has a sister, and dad's self-employed. Is that really the best way to go about it? Probably not, but unfortunately that's where education had gotten to. There's got to be some category of people that public education isn't hitting, and now we're going to do so many things in public education so we can possibly influence that kid. Well, that kid that we just tested is now gone off into the real world. So now we're like, okay, we're going to change for the Native American males on the free and reduced lunch, we're going to change our system. And Cherry Creek looks at it and says, well, shoot, we don't have any Native American males on free and reduced lunch. We have Native American males, but they're not on free and reduced lunch. Oh, no, that's not the category we wanted. Okay, Cherry Creek High School, what are you going to do that you're going to show you are making a difference on the Native American male on free and reduced lunch? Well, we don't have any. Well, what are you going to do to show that you don't have any? This. That's not good enough. Ooh, a little tricky, slippery slope. Massaging the data is something that people like to do. Massage the data to get what their influence is. The last one that we talk about is called a stem and leaf plot. Stem and leaf, pretty easy. Yeah, this bar here, and the one that they have down there, they have this written, and I'll tell you how this goes. Okay, let's see how quick you guys are. What number does this represent? 22. 22. Which one does this represent? 25. This one. This? You guys understand how it goes? Hey, how do I find the middle of this data? The median? Yeah, we got to find the middle. So we're talking about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 numbers. What is the middle of 15? 7.5. Wait a minute. So if I go 1, 1, still with me? 2, 2, still with me? 3, 3, 4, 4, 5, 5, 6, 6, 7, 7. My 8th number is exactly in the middle of this data. My median of the stem and leaf is the number 46. Okay? Could I find the average of this number, of all this? Yeah, I'm going to take 22, 25, 34, 35, 41, 41, 46, 46, 46, 47, 47, 49, 54, 54, 59, and 60. Add them all together and divide by what? 15. Why 15? Total numbers. Okay? So this is all stuff I'm pretty sure you have heard about at some point in your life. Agree? Nope. Okay, well, you missed out on something. 3, 2. The mean, median, and the mode. It's all a way to describe data. The mean is called, we will call it X bar. At some point, X bar is going to change to something different as another variable, but for right now, we're going to call the mean X bar. Okay? The median is called X hat. X hat is the middle of our data. Our data has to be in least to greatest order. Find the middle of it. If there's an even amount of numbers, you have to take the two center numbers, add them together, and divide by 2 in order to get X hat. And then the mode, we're using the Greek letter mu. Mu naught is the mode. The mode is the most occurring number. If you have a list of numbers, ask for the following. You have a list of numbers. Can a number happen multiple times? So the number that happens multiple times the most often is called the mode. Can the mode be multiple numbers? You had a string of numbers and the number 36 happened 10 times, and then you had the number 57 happen 10 times, and that's the most occurring. There's 2 modes. It's called bimodal. You had another number that happened 10 times. It would be trimodal. keep going. Okay, so the mode is the most occurring number to take place. Yeah.
So if you had two numbers that occur at the exact same time, then it's multi.
Bimodal or trimodal or quadmodal or polymodal. Yeah, I know.
Okay.
All right, so the resistive measures. The median is not influenced by outliers. Okay? The median is not influenced by outliers. So let's say if I were to say to y'all right now, hey, empty out your pockets, let's count how much money you had. We can find the average amount of money, and then you got some freak show kid that's got $10,000 they're walking around with. Anyone got that with them? All right, you guys saw nothing. So if I were to ask you all to empty out your pockets or your purses, and we were to count how much money each person had, we can find the average amount of money. The average, if someone were then to say, I have $10,000 in my pocket, that's going to influence the average. Shh. It's not going to influence the median. What am I doing? I did what 6 times? I did absolutely nothing. Sorry. All right. Let's talk about our shapes of data. This is like in 3.2, second page. Describe that shape to me. Looks like a bell curve. Okay. If I were to do this. What does that mean? What does that mean? The what? The mean and the median. Does that mean the mean and the median are the same thing? So if the mean and the median are the same thing, the mean is the average of the numbers, the median is the exact middle of the numbers. So if I had the exact middle of the numbers, what do you know would be to the left of the median? How many numbers? Half. How many to the right of the median? The other half. So if the mean and the median are the same thing, and half the numbers on to the left of the median, and the other half to the right of the median, this would be relatively symmetric. Relatively symmetric. Okay? Things that you could do right now to show this type of curve as a histogram is if you had a pair of dice. 2 dice. Sum of the dice range from 2 to 12. What's the most occurring number with a pair of dice? Pair. Add them together. Huh? 7. If I were to continue to roll a pair of dice, and I rolled it like 10,000 times, and I recorded each time, I'm going to get a relatively symmetric curve to where 7 is the highest rolled number, 6 and 8 are the next rolled numbers, 5 and 9 are the next, 4 and 10, 3 and 11, 2 and 12. Okay, it's going to be very symmetric about that when you roll the dice. If I were to take just one die, if I took a single die, is any number more likely to show up than another number with a single die? No. You roll a single die and you can get 1 through 6 on it. Does that die remember what number came up? No. If I keep rolling that die 10,000 times, you're going to get a relatively uniform graph, and that's going to look like this. In this case, there is not a mode because everything's the mode. Everything happens the same amount of times. Okay? So if it's uniform, you're getting the same number of numbers all the way through. If you have an outlier, it can happen 2 different ways. Okay? This is tugging this way. This is tugging this way. So this would be this would be the situation of that little old lady's house in the middle of Cherry Hills Farms. That's a 2-bedroom, 2-bathroom house. Her house is worth down here. It's tugging to the left. It's skewing left. Whoa, come on, catch up with me. Uh-oh. This scenario is like if we were to take the average of the money in your pocket and you get the one kid in class that has 10,000 bucks in their pocket, this is skew right. Okay? Okay. If something is skew left, it's being pulled to the left. So the mean is going to happen this way. The median is going to stay planted. If it's skew right, the median stays planted with half the data on one side, half the data on the other. The mean is pulled that direction. Okay, so the average. Okay, we already talked about bimodal. That means if you have two modes, most occurring numbers, trimodal would be 3 same occurring numbers. And then I think if I work this example, we'll be good to go. Okay. Type of distribution. 2, 2, 2. Okay. If I wanted to take a look at what this distribution would look like, I have the numbers 2, 3, 4, 5, 6, 7. How many 2s happen? 5? One, 2, 3, 4, 5. How many 3s? How many 4s? 2, but thanks for counting. How many 5s? 2. How many 6s? How many 7s? Describe this graph. What does it look like? Let's do this. Skew right, skew left, symmetric. Skew right. So, out here is pulling it to the right. So, does the mean rest to the right of the median or not? Does the mean lie to the right of the median or not? Yeah. So, you'd have your median, your mean. Okay? Shh. All right. I think, tell me that. 41? Oh my goodness, we got good time. Okay, so I want to show you a couple of things with the calculator. If you have your calculator, get it out. I have to sit here because my calculator doesn't work as nicely as yours. It's not working. No, you're absolutely right. But for some reason, this one has gotten goofy. So I have found through trial and error that it's working here. All right. So let's take a look at worksheet 3.2. You with me on this one? Worksheet 3.2. You with me? You on that page? So I want to plug in this data, and I want to find the mode, the median, the mean, the shape of the distribution, and things such as that. Okay? So let's plug the data in. So on your graphic calculator, in the stat mode, we're going to edit. If you have anything in your stuff, go to the top, hit clear, then down arrow, so it clears your lists out. If you're missing list 1, then let's just go to list 2, and I'll show you how to deal with that. Once you have your list, go ahead and plug your data in. So I have 11. Worksheet 3.2, top. 11, 13.
Rihanna just has better receivers. Yeah. Literally.
Okay, so I think there is 21 pieces of data.
No, this year wasn't bad. The home run derby.
If you're following along using your calculator, are you okay? There are 1, 2, 3, 4, 4 14s. Thank you. 2 15s. 2 16s. 2 17s. 18, 19, 20, 21. Okay, once you plot your data in here, go back and hit Stat. Go over to Calculate. And we're going to calculate one variable statistics. Now, if you did not go under list 1, do this. So you hit one variable statistics, and then whatever list you're under, hit second list. So I want to do the one variable statistics of list 1. If you plug into list 2, do the one variable statistics of list 2. But if you hit enter, this is going to give you X bar. X bar is what? Mean. Then I have the summation. What does that mean? What does the summation mean? What's the summation? What is summation? Yeah, I added them all up. That's all I did. And then this is a summation of if I square everything and then add it up. And then you have S at X and this Greek letter at X, which we'll go over a little bit more. But these are standard deviations. We're not going to worry about yet. We'll get there. What does this n equals 21 mean? What does n equals 21 mean? Amount of data, number of pieces of data I put in. And if I scroll down, I have a minimum value. That's probably the least amount, which is 11. I have a Q1, which we'll go over next time, which is going to talk about, or the box of whiskers. I have a median. Median is known as what? X hat. Okay. Median is also sometimes referred to as Q2. Then I have Q3, which is 17. I have a maximum amount, which is 21. And that gives us about everything that we can do with that. Now, autographing calculator. If we wanted to take a look what our graph looked like, I'm going to go second, stat plot. I'm going to make sure my stat plot's on. I'm going to go to number 1, it's on. And I'm going to go down to the type. And I want to make it look like a histogram. So once you get over to histogram, you hit enter. Whichever list you're on, you want it. So if you're on list 2, make sure that says list 2. And then frequency. Once you're done with that, hit zoom. And then find zoom stat. Zoom stats, number 9 on mine. And so that is the histogram of my data. And the nice thing about this is if you want to do a trace command on this, so we went to, actually I'm going to go back to trace. If you go and hit trace, it's going to be in the middle of this. It's going to say, hey, m equals 11. What does this n equals 4 mean? What does that n equals 4 mean if x equals? Yeah, there happens to be 4 number 11. If I move it to the right, I'm still tracing. And it gets to the top of this one. This is 13. What does n equals 7 mean? Seven pieces of data there, 4 pieces of data here. So, guys and girls, friends, let's talk about this. Look back at our original list. Our original list is 11, 11, 12, 12, 13, 13, 13, 14, 14, 14, 14, 14. So, minimum equals 11. What does this mean? Maximum is what? Is it 13? Other way. Less than 13. So this is meaning my values that are 11 and 12. So my minimum is 11 and 12. My numbers that are 11 and 12, there's 4 different numbers of that. Do you agree? 11, 11, 12, 12 is my list. Then I move here. My minimum is 13. My maximum is less than 15. So which numbers? 13 and 14. Okay? 13 and 14. I have 1, 2, 3, 4, 5, 6, 7 numbers for my list. 7 there. So realize what the calculator says. Okay? So guys and girls, what I want you to do is I would like you to work on which is checked off tomorrow. Worksheet 3.2. It's measures of center. It's only 1 page. I will mark this off tomorrow. So have it, have it, have it. Okay? So 3.2 is what I want you to work on for tomorrow. For homework, it will be checked off tomorrow. And you guys did awesome. I would dismiss you, but I can't.